In this video, we're going to demonstrate the carbon snake reaction. And so what we have a mixture of sucrose and baking soda or sodium bicarbonate, and mixed it up really good in here. Basically, I had 6 grams of sucrose and 1 gram of baking soda or sodium bicarbonate. And in the graduated cylinder, about 20 milliliters of isopropyl alcohol. And we just have some sand. What we're going to do is we're going to soak the sand with the alcohol and try to spread it out as much as we can so that the sand is just saturated with it. And we'll let it seep through there. Let it go down. I'll get some more in there. So about 20 mils in there, and you could do this on a bigger scale. Try it, test out, see what happens. I did it on a bigger scale earlier with about 25 mils, and I added some more sand. I have about 70 grams of sand in my evaporating dish. What I'm gonna do is I'm gonna take and pour my mixture of sodium, of sugar and the sodium bicarbonate. And what we're gonna do is we're going to light up my material. And we're gonna let it burn and see what happens. Now we got a pretty good flame here. The other video, if you saw, I did it in a fume hood and the flame was ripping a little bit. And I wanted to try it on a lab table just to see how it would go. We're getting a nice caramel flavor, or aroma, I should say, because the sugar's burning. So if you've ever had baked goods or baked stuff, you get that smell of the sugar burning. And obviously it's a big flame because we got a lot of isopropyl alcohol in there. And so the reaction that, the reaction that's taking place is actually a multi-step reaction. And so as we go through and this burns, one of the first things that happens is that sucrose is reacting with oxygen that's available, and it's going to produce carbon dioxide and water. So that's your typical combustion reaction. The sugar is going to be burning. But then some of the other things that are going to happen as well is that the carbon's forming. And so the carbon is that actual black snake. And so right now I have 2 smaller ones going. We're hoping that we'll have a bigger one start to take off. If you saw the other video, I'll try to put a link in here to the other video. That whole center area was a very big sample. And so again, that's what happens when you test these out. Sometimes you might get small ones, sometimes you might get big ones, just depending on how the situations and the conditions are. And so what then also happens, we have to consider, is that the sodium bicarbonate is going to break down, in this reaction, and it produces carbon dioxide gas. And when that carbon dioxide gas happens, and we'll zoom in here, see if we can actually see it a little better. But at the very bottom, when the carbon dioxide gas is being formed, it actually causes that snake to be pushed up. So we can see what looks like some bubbles and some popping and fizzling and sizzling down there at the bottom. That's because the generation of carbon dioxide. So we're starting to get a thicker sample for our carbon snake. And so that carbon dioxide production ends up making it continue to grow. And because I have that sample of sugar with the sodium bicarbonate left over, it's a continually fed reaction. So I'll zoom back out here. Notice we have a couple little ones forming. As this continues to grow, we'll hope to have a bigger one that forms. And we're just gonna let this run. And again, like I said, this is a sample experiment. Whether or not I have my students do it or not, or we just watch it and observe it as a demo, I wanted to make sure that it is controlled. I wanna make sure that, it doesn't get too hot. There could be a breakage in the evaporating dish, so make sure your equipment is good and legit to go with for safety precautions. Make sure you keep your containers of anything that's flammable away so those don't catch on fire. And make sure, obviously, you're using the right materials and the right combination. The only thing that I changed right now in this scenario, because I wanted to be able to see if I could do it on a microscale for the students, I used a little bit less of the sand. The sand really is just there to help absorb some of the heat and to allow the reaction to have a place to exist. So you're not just doing it straight on the glass, you're not doing it straight on the lab table, but any big tray you had, you could probably use a pile of sand or a big sample of sand and just throw that in there. So if you notice that one in the back is starting to get a little bigger, it's continuing to grow out from it and grow out to the back. And so if we change our angle here a little bit, you can actually see that a little better, how that's grown. If we zoom in, we can see through the flame that reaction is going pretty quickly in there. We're seeing a lot of production of carbon dioxide, a lot of production of the bubbles, and therefore that carbon dioxide is forcing that to rise up, because those carbon dioxide bubbles get trapped in that hard, not calcified, but carbonized material. And so now we have another bigger one coming out this way. So if we kind of change our angle here, we have two that are coming out, so maybe like ram's horns. And so we have a third one coming out as well. Sometimes you just never know which direction that carbon snake is going. Now, when I did it earlier, I did it in the fume hood, so obviously that's going to take away some of the odor. When you actually do it without a fume hood and without the more ventilation, you're going to smell. But I do have ventilation set up. I am in a lab, in a chemistry room, and right up above it we do have vents, and so that does pull it up. I have vents up above as well in the lab area. You may hear some fans running in the background. So we have a lot of ventilation in here, and we continue to see this go. And when I did it in the fume hood, it actually went very well. So again, check that video out as well. There should be a link below to the other video. I don't talk as much through that, just basically more for observational purposes. And one of the cool things is that went for about 14 minutes. So if that's the case, we're about halfway there. I'm gonna stop talking for a while. You might be able to tell my voice is a little raspy from teaching and talking all day. And we're just gonna let it go and enjoy the carbon snake. I'll zoom out a little bit so we can see more of it grow. Now one of them seems to be taking over instead of those three little ones. We now seem to have one big one. So I'm just gonna change the angle a little bit. Notice it continues to grow and grow and grow. Now the material itself is actually very light and very soft. So I'll give you an example here of what I'm talking about. Pull out some lab equipment. If I try with a pair of tongs, I got some tongs here. If I just try to lift it up, it lifts up very easy, but notice this part broke off. If I try to grab it with any force, notice very easily it squishes and breaks up, okay? So there's not a lot to it. It's basically like having like a sponge of carbon ash. So it's very soft, very lightweight. If you're having a campfire, you a lot of times notice the ashes and little particulate matter flying up into the sky. And that's pretty much what it is too. So it's very light and very fluffy when you actually take a look at it or to actually feel it. If you were to do that in your fingers, it would just crumble and fall apart as well in the same regards. Taking a look at it from this angle right now, it kind of looks like marshmallows burning on the fire. You notice when you burn your marshmallow, you get that same color. It turns black and it starts to expand and get bigger because again, you're starting to release carbon dioxide. When sugar burns, you obviously have carbon dioxide and water that are given off. So having marshmallows and roasting marshmallows, somewhat similar, but obviously that doesn't continue to grow like this. You notice the flame is getting a little smaller. Obviously, we've burned off a lot of the original excess isopropyl alcohol, but the reaction sort of starts to feed itself. And so any of the sugar and sodium bicarbonate mixture that's on the bottom is still going to be basically self-propelling and self-feeding, because those chemicals are still there. There's some fire going, they're burning themselves, and then it's going to be able to, as it rises, it's going to be able to have contact with some of the fresh material that's below it and underneath and continue that reaction. And so we're a little under 14 minutes this time. Like I said, the other one it took about 14 minutes. So this one a little bit different. And one of the big concepts, again, what we have covered here is basically decomposition. We broke down a large sugar molecule, we turned it into carbon dioxide and carbon, which is, and obviously are smaller molecules and smaller elements. So in this case, it was a combustion reaction. Combustion is the burning of, an organic or burning of materials in the presence of oxygen. So we had that as well. And I believe we just kind of ran out of the fuel. Looks like I do have some of the material still on the other side, but we have a really nice product here. We have a really nice sized carbon snake.